You've all probably heard the term perplexity, especially with the context of a language model. But what does this actually mean? So, perplexity is a metric that is used to evaluate language models. It was a measure that was introduced in 1977 by researchers at IBM. Now, if you know what the term perplex means in English, perplex means confused, right? So perplexity is trying to measure how uncertain a language model is in predicting the next word. So what does a language model do? Well, given a set of words, what the language model has done is it's trained on a lot of data. It's given a lot of information in the form of literature. It probably is been fed a lot of books, papers, websites, and so on. And the language model essentially learns the probability of a word being the next word given a context, meaning a previous set of words. And once the language model has been trained and has learned this probability, right? So in our case, given all these words, what's the probability of pizza? Then when you evaluate the language model and you give it a set of words, the language model computes this probability. It has a set of choices that it comes up with and it picks. So if you assume in our case, we're picking the word with the highest probability, which is not always the case. But if you say that, then it says, well, actually, pizza, based on its computation of this probability, has the highest probability. And so that's the next word. Now, what perplexity does, right, to get that, what we can do is, let's say this language model has these probabilities for these words, right? And so it's predicting the next word, and each word that it predicts has this probability. So the probabilities are already there with the language model. What you do to compute perplexity is you say, well, first, how many words are there in our test set, or in this case, it's a sentence. There are n words, which is 8. So we have 8 words or tokens. We first compute the log of each of these, right? And then we average it. So you take the sum and divide by the number of tokens. And then we take the negative of that and compute the exponential of that. So we compute the exponential of the negative average log probabilities or log likelihoods. And that is our perplexity. So for this simple sentence, it would be the negative of this, which would be 1.842. So the general formula is basically taking the log probabilities of each of those tokens, which the language model should have, averaging that. So you basically effectively getting the per word probability. So you take the log, you take the sum of that and divide by 1 by n. You're getting the per word log probability. Take the negative of that and exponentiate that. So it's the exponential of the average negative log likelihood, which is just log probability, right? Now, in our case, we have said the perplexity is 1.842. What does this mean? It means that for each word, because it's the averaged probability, log likelihood, negative log likelihood, what it's telling you is there's 1.842 equally likely options that the model could have picked for each word, right? Now, how good is this number? Well, actually, in this particular case, it's quite good because it's telling you there aren't that many options that the model could come up with for each word. It was fairly certain of each word. So in the ideal scenario, the perplexity is 1. It knows for sure what the next word is that it's going to come up with. And so the perplexity is 1. In reality, you'll see much larger numbers, right? First of all, as you have seen, the perplexity depends on the test set. Of course, on the model, right, which has the probability. So the better trained model, on the more data it's trained, good. And then it depends on the test set that you're testing on. Ideally, that test set is different from the training set. And for a large test set, expecting a very low perplexity of 1, 1.1, and so on is not great. But the lower the perplexity, the better. So if you look at papers, you'll see perplexities anywhere between 10 and 20 and 30, which isn't bad given some of those test sets are millions of words, right? And if you have, say, perplexities above 100, you're saying, well, the model is quite confused because for each word, it could have come up with one of 100 choices, right? Which means the model is not very sure. Now, perplexity is related to a term we're probably familiar with, which is cross entropy. So this term that actually you're exponentiating is actually the cross entropy. And I'm not going to do the derivation here, but this is, something you can actually go and refer to in more detail. So perplexity basically can be computed by basically exponentiating the cross entropy loss, which for most models, when you compute, you say using PyTorch or something like that, you can very quickly get this cross entropy loss, right, for the words. And then when you exponentiate that, you can calculate the perplexity. So that has given us an understanding of what perplexity is. Now, you've probably understood this by now, but something to keep in mind, it does not measure how accurate the model is, right? Because for accuracy, you need an exact answer, and we generally don't necessarily have an exact answer. What perplexity is telling you is how confident the model is. It's telling you that if the probability that the model is predicting each word is very high, it's confident. Now, for our case, for example, it could give you a wrong answer, right? But the model, if it's very confident, the perplexity will be low, right? Because the probabilities will be high and the perplexity is effectively the inverse of that, right? And on the other hand, it might actually come up with an answer that makes sense, but if the confidence is low, the probabilities are low, it's not very confident, the perplexity will be high. So the lower the perplexity, the better. So hopefully this has given you a good understanding of the term perplexity. And the next time you see it, in a research paper or in an article where it's been used to evaluate a language model, you understand what it is. Great. See you in the next one.